Hello class, this is I believe going to be the last video, and I don't think it'll be too long. We're going to walk through the solution to Quiz 5 and Quiz 6. So there's basically two types of problems you see with sequential analysis, which is what this quiz covers. Put the date on here for 21/20. And in this case, you are given the state table. That's the easy one. And I've covered this in a previous video, so we can get right to work on this one. Make sure that you read the directions carefully on all these problems. For the following state table, that's this guy. Show a state diagram, so that's the bubbles with the arrows. Complete the timing trace. So I know I've been using truth table TT here, timing trace. And then is this a Mealy or a Moore model? Pause, see if you can get the answer to that. Okay. Mealy. See, when we're in state A and X is 0, here's Z. When we're in state A and X is 1, here's Z. So they happen to be the same for states A and B, but for C it's different. Even still, having these two columns indicates Mealy model. Now, if both of these were the same, then you could argue that it's actually a Moore model, because it doesn't really matter what X is. But in these two cases here, it's different. Now, of course, if this was a design problem, we could go through and design this, but we're not actually going to do that. Because it's a Mealy model, in the state diagram, output goes on transition. That is the arrows. So we'll put X over Z on each arrow. So a 0 causes us to go to A. From A. And when X is 0, the output is a 1. If X is a 1, we go to B. Just remember, for a Moore model, the output goes with the state itself. But this is a Mealy model. Alright, so a 1 takes us to B, and our output is also a 1 in that case. You could have put B over here, you could have put B up here. I mean, however you want to rearrange them. I just happen to go this direction. From B, if X is a 0, we go to D. That's this one right here. The output is 0. And from B, if X is a 1, we go to C. The output is also a 0. Alright, from C, if X is 0, we go back to B. So that was this transition that we just drew with this arrow. And output is a 1. Remember, this is X over Z in each arrow. Input over output. So now, if X is a 1, we go to A. So we just did this transition, and we see that the output is a 0 in that case. So that takes care of that row. Now we do the last row. We're in D. We go to C if the input is a 0. that transition, and the output is a 1. And then finally, we go from D back to A when the input is a 1. And the output is 0 there. So that's the state diagram. We're already given the state table. We did that part. Now we're looking at the timing trace. We could have started with the timing trace. We have all the information here. Again, it's just another piece that we're supposed to do. So we're given that we start in state B. We can look up, I generally like to do all the states, then all the outputs, but I'll go ahead and start with your first output here. B, input is 0, means the output is 0 right here. So remember, both of these, the 0 and the B, determine what go here. And so B, 0, we go to D. D, X is 0, so we're in state D, X is 0, means we go to C. C with a 1, C and a 1 means we go to A. A with a 1 means we go to B. B with a 0 means we go to D. D with a 1 means we go to A. A with a 1 means we go to B. B with a 0 right there means we go to D. We go to C or A here. We just don't know, because we don't know what the input is. Make sure I did that right. Check my key. Yep, looks good. Alright, now we use this 0 and this D to show that our output is 1 here. X is 0, we're in state D, output is 1. C with a 1 is a 0. A with a 1 is a 1. B with a 0 is a 0. D with a 1 is a 0. A with a 1 is a 1. B with a 0 is a 0. D, we don't know. It depends on X. And there you have it. So that's all for number 1 on quiz 5. Okay. So on this one, I kind of give you what you need to do, but I also did it because I would sometimes receive submissions that just filled this out and didn't do any work. And, you know, this is what I want to see. This is really telling you how to do it. So this is the other type of problem. We are given a circuit, and we have to come up with everything else. So kind of working backwards from sequential design, here's the circuit. Where did it come from? How does it work? Now, you can check your work on these. You could take this circuit, build it in Logisim, check your work. I encourage you to do that, but I need to see the work here too. So just putting this into Logisim and programming it in and seeing what happens, that'll check your work, but I need to see you actually put this together. Again, for the quiz, you're just copying what I've got. This is the right answer. I just want you to submit your work through of the quiz. All right. What is Z equal to? Q2 naught and Q1. So is this a Mealy or a Moore model? Pause and come up with your answer. Give me a hint. Starts with an M. Moore model. There's no X here. So Z does not depend on X. Makes it a Moore model. Alright. Also, D1. Very simple. Equal to X naught. J2 is equal to Q1 or X. K2 is equal to Q1 naught. So now we put together our state table. Should get our ruler and do this very neatly, but looks like it's going to turn out okay. Probably more width than I need. So what we're trying to figure out now is Q1 next, Q2 next. So here's where you have to know how the flip-flops work. For a D flip-flop, the next state is the value of D. So I don't even care at all about anything except really this column. The next state on Q1 is equal to X naught. So let's say that X is set at 0 and my clock's ticking along. This will just stay at 0. As soon as I flip X to 1, the next clock tick, whether this is a rising or a falling edge, I'm not sure, it doesn't matter. Next clock tick that causes a change will cause this to go to 1. That's the way the D flip-flop works. JK flip-flop, a little bit more complicated, so I'm going to put some work over here, and I'm going to write my values of JK in to help me figure out what happens. So J2 is equal to Q1 or X. So if Q1 is a 1, I don't care what X is. So in these two rows and these two rows, that's the case. Now also down here, X is a 1 here, so I don't care what Q1 is. And in these two rows, both X and Q1 are 0. So there you go. And this is just equal to Q1 naught. So 1, 1, 0, 0, 1, 1, 0, 0. So this is reset, reset, set, set, toggle, toggle, set, set. Remember, a 0, 0 would mean that the state stays the same. So resets, both of those rows are 0. Set, both of these rows are 1. I don't even care what the current state was, because reset and set, reset means it goes to 0. Set means it goes to 1. Toggle means it goes to Q2 naught. So here Q2 is 0, so it becomes a 1. Here it says 1, it becomes a 0. And these are both 1s as well. I left out my Z. Let's go ahead and put him in. Now, why did I mark that out? Because Z doesn't depend on X, I don't care about that. So I've only got 4 possible values of Z. And here are the inputs, Q1 and Q2. So this is equal to minterm 1, 0. So this is our only 1, and everything else is a 0. You could write it in again down here, and it would just duplicates, because it's the same values for Q. So those are from the equations from the circuit. Q1 next equals D1, which is equal to X naught. That's where that came from. Q2 next. I have written in my notes and you could do it this way. You could also say Q2 next is equal to J2 Q2 naught or K2 naught Q2. I don't like to do it that way. I do it this way, and that's what I just demonstrated. So that's, oh, well, that's not the whole problem. Now we have to go up here. So, try to point at both sides. Again, you're giving a start state of 1, 0. So, really, we can just read the row off the state table. 0, 1, 0. 0, 1, 0 means we go to state 1, 1. 1, 1, 1 means we go to 0, 1. 1, 0, 1 means we go to 0, 0. 0, 0, 0 means we go to 1, 0. 0, 1, 0 takes us to 1, 1. 0, 1, 1 takes us to 1, 1. 1, 1, 1 takes us to 0, 1. 1, 0, 1 takes us to 0, 0. 0, 0, 0 takes us to 1, 0. 1, 1, 0 takes us to 0, 1. Now we don't know what the input is, so we could be here, or we could be here. If we're here, we go to 1, 0. If we're here, we go to 0, 0. In either case, Q2 goes to 0. Don't know what Q1 does. And then you can even take it a step further, look at all the rows where Q2 is a 0. So that's here, 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 and here, all 4 rows. Well, here we could go to 1, 0. Here we could go to 1, 1. Here we go to 0, 1. Here we go to 0, 1. So we don't know at all what comes next. Quick and easy way to do this, again, we're looking for minterm 1, 0. So 1, 0, 1, 0, 1, 0. We don't know if this is a 1, 0 or a 0, 0. So we don't know. And everywhere else it should be a 0. You could again take these values 1, 0 and plug them in to this row of the table. 1, 0, 1, 0 here, 1, 1, 1, 1 here. But just going from the fact that we know that this is just simply this one minterm, very easy just to go through and fill in all the ones. All right, so that is quiz 5. Please let me know if you have any questions. Now we'll do number 6. Quiz number 6. This is sequential design. Reversal there. All right, some things to note. There's no X. There's no Z. So what do we do? And I've received a few questions about this on other homework problems. So you leave them out. This is a quiz question. It's designed to be a little bit simpler. We'll encode our states like you would think. And with a counter, that's generally the default. So 0, 1, 2, 3. You could draw a state graph, but you don't really need to. I'm going to draw a simplistic one. There it is. There is no output. It's just going from state to state. So I'll call it Q1, Q2. Q1 next, Q2 next, J1, K1, J2, K2. Alright, so 0 goes to 3, 1 goes to 2, 2 goes to 0, and 3 goes to 1. This is our design table. So we're just looking at the Q1s. I think this pencil will get in the way of me writing, but you'd also mark those out. Don't look at them. Through talking with students this week and demonstrating things, a straightforward way to do this is put this in Excel and you can hide the columns you don't want to look at while you're filling this in. And then you just copy and paste from Excel, especially since you're doing the work at home. Don't have to write it by hand. Do this in Excel. Alright, so 0 to 1 on both of these is 1x. Here we go 1 to 0, and then 1 to 0 again is x1, x1. You can already tell that looks nice. If you don't see why, you will in a minute. 0, 1, 1x, 1, 0, x1, 0, 0 is 0x, and 1, 1 is x0. Don't really need K-maps for all these, but that's all right. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Alright, 0, 0 and 0, 1, both 1s, both X's. X's here, 1's 1s. You can go back and check the values, but you know, 0, 0, Q1, Q2, 0, 0 is this row, this row. You know, we have this row, this row. So we have 1x, 0x, and x1, x0. J1 equals 1. K1 equals 1. And let's kind of explain that. Go back and do more than just write this out, but understand what's going on. So when J and K are both 1, what does this flip-flop do? Pause it and think about it for a second. The answer is that it toggles. Q1, next state, is always flipped. So these are always going to be a 1. J2 equal to Q1 naught. K2 is equal to Q1 naught. That one doesn't have a nice simple explanation. So, you know, I received a few questions like, what does it mean design the circuit, design the system? Well, this is the system. This is your, it's like a lab, only you don't have to build it. You don't even have to do it in Logisim. J2 and K2 are equal to Q1 naught. Q1, Q2. There it is. And this will now count 3120, 3120, 3120. So about half of the final exam will be these types of problems. They're honestly going to be a little bit more complicated. They'll be somewhere between this and the homework, or maybe right in line with the homework. Because originally the test was designed to be done in 2 hours in class, closed book, closed note. So since it's open book and you have a lot of time to do it, the questions are going to be a little bit more involved. So, you know, you may have an X, you may have a Z. You know, this problem, you had 2 flip-flops. Maybe you'll have 3 flip-flops that you have to deal with. You know, like I said, the questions will be a little bit more involved than they would have been if we were taking the test in a closed environment, since you have more time to work on them and can research and take your time and do them carefully. Alright, well, I think this is going to be the last video. I will scan this and it'll all be posted soon. Thank you.